Hi guys, today we're going to talk about how you calculate a number that has had a percent increase or decrease. This is a skill that's learned in junior high, 7th, 8th grade, maybe 6th grade. So for our high school algebra, this should be a review. We're going to go through a couple of ways, and I'm going to show you how to do this by hand without having to use a calculator. Okay, so if you get a question like, what is the result of a number? Let's go with, let's say 96. So what is the result when 96 is increased by 25%? Okay. So first of all, increased, we know that we're going to be adding. Okay. Increased is an adding. We're going to need a number that gets bigger than 96. Okay. We have this 25%. We want to convert 25% to a decimal because that's what we have to multiply by. We can't multiply by a percentage, so we're going to convert that to a decimal, and it becomes 0.25. Okay. So then I'm going to take my 96. I'm going to multiply it by 0.25. Okay. Now, all my algebra students that have had me in class are going, but Ms. Johnson, you said never use X in algebra and to multiply. And you're right. I generally tell you not to do that because X signifies a variable in Algebra 1. But we're kind of taking things back to middle school, back when we did use X to multiply. So we're going to go back old school and say 5 times 6 is going to give me 30, and I'm going to carry that 3. And 5 times 9 is 45. I'll add the 3 to get 480. And then I'm going to do my 2. So 2 times 6, I'm going to put 0 here. 2 times 6 is 12. And I'm going to carry that 1 now. So 2 times 9 is 18, plus 1 is 19. And then I'm going to add these together. And that's 10, so I carry my 1. I get 14 and carry that 1. Well, now I have to deal with my decimals, okay? Because I have this decimal. I have 2 digits after decimals here, so I need 2 digits after the decimal. My answer, that should be a 2. All right. Yes, it's been a it's been a minute since I've had to do the old school multiplying. All right. So I've gotten so used to use my calculator, even I have to remember what I'm doing sometimes. So 24. The answer is 24. Okay. Sort of. Okay. That 24 is 25% of 96. Okay. So now I have to take that 96 and add 24. So 96 plus 24, we're going to get 120. Okay. So there's my solution, 120. Okay. That is 25%. That's 96. That's increased by 25%. Thank you. All right. So now there is another way to do this, and I'm going to show you an alternative method here. 25% is 0.25 as a decimal, but 0.25 can also be converted to an equivalent fraction. Okay, so 1/4. Okay, 25% is 1/4 of 100. So what we could do, instead of multiplying 96 by 25, we could divide 96 by 4. Okay, so 4 goes into 9 2 times, and we're going to carry that 1 left over because 2 times 4 is 8. So 9 minus 8 is 1. And then I look at 4 into 16. Well, 4 goes into 16 4 times. Look, there's our 24. And again, like we did before, we'll just take the 96 plus 24 and get 120. Okay, so there's two ways you could do this. You could either multiply by the decimal, or you can divide, you can use the equivalent fraction. Okay, for those of you that the upside down division doesn't make much sense, all I really did was I took 96 divided by 4. Okay, and when I simplify this fraction, I get 24. Okay, all right, now what if it asks about the result when 96 is decreased by 25? Okay, so let's I'm going to kind of put that down here. If 96 is decreased, meaning we're going to subtract, it's going to go down by 25%. Well, we're going to start it the same way. We're either going to multiply by 0.25 or we're going to divide by 4. Okay, so we're still going to get 24. In this case, all we're going to do is take the 96 and subtract 24. So when I subtract 24, I'm going to get 72. Okay, so if I'm increasing by 25%, I get 120. If I'm decreasing by 25%, I get 72. Okay, now if you like this method of just dividing by the fraction, okay, there are some common percents to fractions that we can use. So some common percent to fractions. So let's start with 10%. Okay, 10% could be 1/10 as a fraction. 20% is equivalent to 1/5. 25% is equivalent to 1/4. 50% is equivalent to 1/2. Okay. Now, there is a common one that people try to use a lot. A lot of times people try to say that 33% is equivalent to 1/3. This is not true. Okay. 33% is an exact value. 1/3 is actually equivalent to 0.33333 repeating. It's not an exact value. It's a repeating decimal. So this is actually not true. Okay. In this case, if you get a 33% as something that you're trying to multiply by, you're just going to have to multiply by 0.33. Okay. It's not equivalent to 1/3. Okay. There are a few other examples we can go through real quick. Let me get to a clean space here. Okay, I'm going to leave our common percents to fractions up there. How about if we want to increase, let's say 25 by 20%. Okay, so I'm going to take, I'm going to do the division one because that is an easier, slightly easier one to do. I'm going to take 25. I'm going to divide it by 5 so that I get 5. And then I'm going to take my 25 and add 5 to get 30. Okay. How about if I want to decrease, let's say 100 by 33%. Okay. So remember, increase means that we're adding, we're going to go up. Decrease means that we're subtracting, and we're going to go down. Okay. So decrease by 33%. I'm going to take my 100, Since I do not have an equivalent fraction for 33, I'm going to have to multiply by 0.33. And I'll get 300 here. I'll get a 3,000 down here. I'll add these up and get 3,300. Put my 2 decimals, so I end up with 33.00. Okay, so now I'm going to take my 100 and subtract my 33. And we are going to do the old school borrowing here, regrouping and borrowing so that we get 7 and 6. So 67 is our final answer. Okay. All right, guys. I will talk to you later. Have a great day. And just remember, keep practicing your math.